All right, let's dive in. We're going to talk about the electrical systems that really power our entire world. But more importantly, we'll focus on how to make them safe and reliable, especially in places where you just can't take a steady supply of power for granted, like in your workshops and clinics.
So, I want you to imagine this for a second. Picture a hospital in Kampala. In the middle of the night, the power flickers, a voltage drop, and suddenly the alarm on an incubator starts screaming. Now, this isn't just some technical problem, is it? This is life and death. So to figure out how we protect that tiny life, we've got to first understand the electricity itself, where it comes from and the journey it takes to even get to that incubator.
You see, the power that gets to that incubator, well, it's had to travel a really long way, all the way from a power plant to the plug in the wall. And along that path, there are points of incredible power, but also some really critical vulnerabilities.
So, electricity gets its start at a massive power plant. From there, it travels across the whole country on what you can basically think of as high-voltage highways. Then, at different points, it gets stepped down at substations to a medium voltage for towns and regions before it makes one final, really crucial step to get to you.
Probably the best way to think about this is to picture a water system. That high and medium voltage stuff, that's like the gigantic high-pressure water mains that bring water into a city. I mean, it's super powerful, but you can't just hook up a tap to it, right? The pressure is way too high. It has to be brought down to a safe, usable level first.
And this is where the real magic happens. This is the distribution transformer. I want you to think of this thing as the critical gateway that stands between that huge, powerful grid and your building. It's what takes that high-pressure electricity and turns it into the stable, safe power that our equipment actually needs to run.
And this is a super important point. That transformer, it's the line in the sand. On one side, you have the national grid. On the other side, that's your world, your workshop, your clinic. That's where your responsibility begins. Its proper function is absolutely essential for everything that happens downstream.
So, let's say we've got the right voltage coming in. Everything should be okay, right? Well, not so fast. Things can still go wrong inside your own building. A wire could come loose, maybe insulation gets old and wears out, and suddenly electricity can start to leak out. And that creates a really deadly hazard. So the question is, how do we protect ourselves from that?
And that brings us to what is honestly one of the most critical safety concepts in all of electricity, the earth connection. Let's go back to our water analogy. If that high-pressure pipe inside your building springs a leak, this is the emergency drain that stops the whole place from flooding. For electricity, it's the system that prevents a fatal shock. It gives that leaking electricity a safe path to the ground.
So, let me be crystal clear here. A proper earth connection, it's not just a good idea, and it's definitely not optional. It is a fundamental safety system. It's what saves lives, full stop. It's what protects the expensive machinery in your workshop, and it's what keeps those critical medical devices in your clinic running safely.
Okay, so we know we need an earth connection. But, and this is a pretty big but, it turns out not all earthing systems are made the same. There are different ways, different strategies for connecting to the earth, and each one is designed for a very specific type of situation. Let's take a look at the main ones you're going to come across. Now, you're going to see a few letters here, TT, TN, and IT. And I know, at first glance, it might look a little complicated, but don't let it scare you. The main difference is actually pretty simple. It all comes down to how the power source and the body of the equipment are connected to that safety drain, the earth. And that one difference has huge implications for both safety and reliability. Okay. Out of these three, I really want you to pay close attention to this one, the IT system. It's specially designed so that if a first fault happens, that first little leak, it doesn't immediately shut everything down. And you can see why that's so important, right? It's exactly why this system is required in places like hospital operating rooms and intensive care units, where losing power even for a split second is just not an option.
And this quote, well, it really gets right to the heart of the matter. Look, you might not have any control over how stable the national grid is. We all know the power can be unreliable. But you absolutely can, and you absolutely must, control the safety and the integrity of the system inside your own walls. Because knowing how to figure out what kind of system you have and understanding how to properly install and maintain your earth connection, that is the absolute key to being resilient. It lets you create a kind of safe electrical island for your facility, even when the sea of the main grid is stormy and unpredictable.
So, if you take one thing away from all this, let it be this.
Understanding these concepts is what gives you the power to guarantee safety. It transforms you from someone who just uses electricity into a guardian of the people and the equipment that depend on you every single day.